So let's start now with the main concepts of the pH partition hypothesis. So according to this theory, or according to this hypothesis, most drugs are weak acids or bases, and they exist in solution as both ionized and non-ionized forms. When we say non-ionized form, this is usually the more lipid-soluble form of the drug. And when we say lipid-soluble, this is a form that can readily cross the cell membrane. When we say ionized form, this is usually the less lipid-soluble form of the drug, and this is usually often excluded from the transmembrane diffusion. So when we say ionized form, so since this is excluded now from the transmembrane diffusion, so this particular form of the drug will usually be trapped at a particular cellular compartment because it will not be able to pass through that particular membrane. So the other name of the non-ionized form is the ano gani yung other term ng ating non-ionized at saka ionized? What is the other name of this or the other term that we are using to refer to the non-ionized and the ionized form of the drug? Anyone? Ano yung other name ng ating ionized and non-ionized form? So yung other name ng ating non-ionized form is the unprotonated form. Ionized naman, this is the protonated form of the drug. So when we say ionized, that particular compound or the drug is, when we say the drug is ionized, it is less lipid soluble, it is less lipophilic, and it is hydrophilic or it is water loving. When we say non-ionized, it is highly lipid soluble, the drug is more lipophilic, and it is hydrophobic or water fearing. Lipophilic or ano siya, fat loving. In terms of the ionization, so when a drug is ionized, it is water soluble. When the drug is ionized, it is less lipid soluble. So when the drug is unionized, now it is water insoluble or it is lipid soluble. So the ionized form of the drug, it cannot readily cross the lipid membrane. For the unionized form of the drug, it is the form of the drug that will readily pass through the cell membrane. For the degree of ionization, so basically when we say ionization, that is the amount of the drug in the ionized or the non-ionized form. So the degree of ionization of an organic compound will depend on its pKa value and the pH of the environment on either side of the membrane. So for weak acids and weak bases, one of the properties that will determine its degree of ionization, aside from the pH of the environment, so one of the determinant of the degree of ionization is the pH of the environment. So for example, yung ating we have the acidic or basic environment. Another property is the pKa of the drug. So this this pKa value is important because it will determine the pH wherein the ionized and the non-ionized form of the drug will be equal. So for example, when we have a smaller value of our pKa, it can tell whether a particular drug is acidic, strong acid, or it will also tell whether a particular drug is a weak acid. It can also tell whether a particular drug is a weak base or a strong base. Now, depending on its pKa value. So these two factors will determine the degree of ionization of our drug, the pKa value and the pH of the environment. So for example, the higher the degree of ionization, it could mean that there can be, the drug is more ionized compared to its non-ionized form. The lower the degree of ionization, this could mean that the non-ionized form of the drug is more predominant than its ionized form. Let's proceed to the logarithms and the pH scale. So basically, it's important not to study the logarithm because this is the mechanism, or this is the method that is being used by scientists in order to quantify or in order to determine the quantity of hydrogen ions that are present in the solution. It is also the basis for the pH scale or for determining the pH of a certain solution. Ano gani yung ating definition ng pH? When we say pH, that is the ano yung ating definition ng pH? Again, acidity or alkalinity. Acidity or alkalinity. Aside from that, when we are going to refer to our hydrogen ions, so basically, pag sinabi nating pH, that is used to measure the concentration of hydrogen ion in a solution. So the concentration of the hydrogen ion will now determine the degree of acidity or alkalinity. So for example, pag maraming hydrogen ions, so ibig sabihin yung solution is acidic. Pag konti naman yung hydrogen ions, the solution can be basic. Okay. So it is said na yung concentration ng hydrogen ion in a solution is very small. Very minute lang yung concentration of the hydrogen ion in solution. So for those scientists na dealing with the pH, they have devised a method wherein they can easily identify the pH or the concentration of hydrogen ion in a solution. And this method is known as the logarithm, or the use of logarithmic scale or logarithm. So a logarithm is, when we are going to interpret a logarithm in layman's term, this is the number of times one number must be multiplied to give another number. So for example, we have here a number 1,000. 1,000 in logarithm can also be expressed as 10 to the third, meaning that we need to multiply our base 10. We need to multiply 10 3 times in order to come up with 1,000. So therefore, the log 10 or the log base 10 of 1,000 is equal to 3, because The 3 here will indicate how many times n will be multiplied in order to come up with 1,000. So base 10 logarithms. So yung ating example kanina, we use the 10, no? 10 as our base. But in other logarithmic scale, they are also using other bases. So for example, we can also use the number 2 as our base. No? So 2, for example, for 16, for example, when you are going to use 2 as our base, so the log base, the log base 2 of 16 is equal to 4, and this will indicate how many times 2 must be multiplied to get 16. And in this case, we need to multiply 2 by 4, or we need to multiply 2 4 times in order to come up with the number 16. So, but for this topic, for the description of our pH, we will use the base 10 log in order to describe our pH. So, to practice, in calculating the log 10 or the log base 10 of the following number. So, for example, we have here our number 10,000. So we can express this in logarithm as times 10 raised to the 4th power. So this means that we need to multiply our base 10 4 times in order to come up with 1,000. For 1 million, so the log base 10 of 1 million is 6, meaning that we need to multiply 10 6 times, 10 times 10 times 10 times 10 times 10. So that is 6 times in order to come up with 1 million. For 1 trillion, our log base 10 of 1 trillion is 12, meaning that we need to multiply 10, the base 10, 12 times in order to get 1 trillion. So what number has a log base 10 of 2? So the number that has a log base 10 of 2 is 100, because we need to multiply. So to get 100, we need to multiply 10 2 times to get this number. So thus a log base 10 or a log 10 increase of 1 represents a tenfold increase in a number. So for example, a log base 10 of 100 is equal to 2. This means that we need to multiply 10 by 2 in order to get 100. A log base 10 of 1,000 is equal to 3. This means that we need to multiply 10 3 times in order to get 1,000. So there is an increase in the number. There is an increase in the log base 10 from 2 to 3. So when we are going to increase the log base 10 by 1, it would also mean a tenfold increase in the number. So in this example, an increase of 1 from 2 to 3 will represent a tenfold increase from 100 to 1,000. So the relationship of the log base 10 to the number is directly proportional, because when we are going to increase the log base 10 by 1, it would also mean a tenfold increase in the number that we are computing. So 2 to 3, 100 to 1,000. So there is a tenfold increase in this number. We also have negative logarithms. So in describing the pH, or in describing the concentration of hydrogen ions, we usually use negative logarithms because, again, the number of hydrogen ions in a solution is very small. So when we say negative logarithm, this represents how many times we are going to divide a number in order to get another number. So for example, when we have here the number 0.001, this means that uh, this is also interpreted as 1, no, divided by 10, divided by 10, divided by 10. And the log base 10 of 0.001 is equal to negative 3. So this means that we need, no, to divide this number by 10 3 times in order to get 0.001. So in scientific notation, this can also be interpreted as times 10 raised to negative 3. So negative 3, no, meaning that we divided the number and our number is less than 1. So at a negative log 10 increase of 1 will represent a tenfold increase in a number. So for example, a log base 10 of 0.01 or 0.001 is equal to negative 3, meaning that we need to divide 1 3 times. No, we need to divide 1 3 times by the base of 10. For a log of base 10 of 0.0001, so this is equal to negative 2. This means that we need to divide 1 2 times by a base of 10 to get this number. So an increase of 1 from negative 3 to negative 2 will represent a tenfold increase from 0.001 to 0.01. So as we all know, negative 2 is greater than negative 3. So when we are going to increase the number, from negative 3 to negative 2, it would also increase another number from 0.001 to 0.01. So 0.01 is greater than 0.001. So this is true for the negative logarithm. So when we are going to apply this in the pH scale, so the pH scale will describe the activity of hydrogen ions in a solution. So the more hydrogen ions that are present in a solution, so the solution will be more acidic. The fewer, so it is basic. So since these concentrations are usually very small, scientists decided to use the base 10 logarithm to describe the pH. So ito na yung sinasabi natin kanina, no, that the concentration of hydrogen ions is very small in a solution. So scientists have devised a way or a method in order to describe it still, no, and this is through the use of the base 10 logarithm. So for example, when the concentration of the hydrogen ions, for example, is 0.000001, this can also be interpreted as 10 minus 7. No, the 10 to the negative 7. It can also be interpreted as simply negative 7. So this is the log base of the log, no, base of 10 of this particular number. The log 10, no, base of 0.001 or 10 raised to negative 7. So this is equal to negative 7. So to avoid working with a negative number, we simply change the sign of the number, no, to 7. So this is how we derive the pH scale, no, the values in our pH scale. So for example, a pH of 7, which is the neutral pH in our pH scale, would mean that the concentration of hydrogen ions in our solution is is this number. This number is less than 1. So this is a very small number. And this in exponential form or in log form, this can be interpreted as 10 to the negative 7. Or it can also be interpreted as 10 to the minus 7 or 10 to the negative 7 moles of or moles per liter of hydrogen ions. So the mole, the unit mole would represent the concentration of hydrogen ions in a solution. So pag negative, ibig sabihin, very small lang yung concentration of that particular molecule sa solution. So ibig sabihin, when a solution has a pH of 7, it means that this is the relative concentration of the hydrogen ions in the solution. So when we are going to increase the pH in a pH scale, when we are going to increase the pH by 1, it would also represent a tenfold decrease in the concentration of our hydrogen ions. So for example, the log base 10 of 0.001, which is equal to negative 3, when we are going to interpret that through a pH scale, so that will be equal to 3. The log base 10 of 0.01 is equal to negative 2. When we are going to put that in a pH scale, that would be equal to 2. So in here, the pH 3, when we are going to decrease now the pH by 1, so that is from 3 to 2, it would also mean a tenfold increase in the concentration of our hydrogen ions from 0.001 to 0.01. So again, 0.01 is greater than 0.001. So there is a tenfold increase in the hydrogen ion concentration when we are going to decrease our pH. So this is why a solution becomes more acidic, the pH will also decrease. So for example, when we are going to decrease the pH from when we are going to decrease, for example, the pH of a solution from 3 to 1, it would also mean a 100-fold decrease in the concentration of our hydrogen ions. So itong 0.001 magiging 0.1, meaning that there is a 100-fold increase in the concentration of our hydrogen ions. So pH is a measure of the activity of the hydrogen ions in a solution. So it approximates the concentration of hydrogen ion in a solution, or it is also the negative base 10 logarithm of hydrogen ion or hydronium ion concentration in a solution. So bakit siya negative? Because bakit nga negative yon? Negative logarithm. Negative base 10 logarithm. Yung ating pH. Bakit nga siya negative base 10 logarithm, yung ating pH? So this is because the concentration of the hydrogen ions in the solution is very small. Napakaliit lang yan, kaya negative base 10 logarithm yung ginamit. So in pH, we are usually focusing on the hydrogen ion. So hydrogen ion has a formula of H plus. So when we are going to review our hydrogen atom, so a hydrogen atom is consists of a positively charged proton. The positively charged proton is located at the nucleus of the hydrogen atom. And we have also here the presence of one electron that orbits our atom. So when we are going to remove the electron that orbits our hydrogen atom, what will be left is our hydrogen ion. So this hydrogen ion is defined as H plus, and this is electron deficient because it has lost its one electron. So a proton is positively charged, an electron is negatively charged. So hydrogen ion is a proton because it is positively charged. So let's now proceed now to our acids and bases. So in this topic, in this discussion, we are going to define our acids and bases into two ways. The first one is the Arrhenius definition of acids and bases, and the second one will be the Bronsted-Lowry definition of acids and bases. So for the Arrhenius definition of acids, it states that Arrhenius acid is a substance that produces hydrogen ion in water. So an example of our Arrhenius acid is HCl or hydrochloric acid. So for example, when you are going to place HCl in water, it will completely dissociate into hydrogen ion and chloride ion. So this H plus here will make this particular substance HCl an acid, because when you are going to add no more HCl in water, so the solution will be having more hydrogen ion, because this HCl dissociates into H plus and Cl minus. An Arrhenius base is a substance that produces hydroxide ion or OH minus in water. So when we are going to put sodium hydroxide in water, so sodium hydroxide is a base. It is a base because it produces hydroxide ion in water. So it dissociates into sodium and hydroxide ion. So that when we are going to when we are going to add more sodium hydroxide in water, so it will tend to produce also more hydroxide ion in water. Kaya tinawag siya na Arrhenius base. So an acid, when dissolved in water, increases the concentration of hydrogen ions. So in this example, we think of acid as H plus generator, and H plus is the proton. So we have here water and our HCl. So anong kulay ito? The green one is the chloride ion, while yung naka-attach sa kanya is the hydrogen ion or our proton. So when we are going to place HCl in water, HCl will dissociate. No, it will break into the proton and chloride, this one here. So there will be more proton in the water. So pag magdadagdag ka ng HCl ngayon, so dadami ngayon yung H plus sa solution or sa water. And this HCl, kaya tinawag siya na Arrhenius base because of this property. For the base, when you are going to put more sodium hydroxide in water, since sodium hydroxide dissociates into sodium and hydroxide ion, so when we are going to put more of the substance here in water, so it will produce also more hydroxide ion in the solution. So the presence of excess hydrogen or H plus or OH minus ions gives acids and bases their characteristic properties. So acids have a sour taste, while bases have a bitter taste because of this property. So when we are going to illustrate the concentration of the hydrogen ion and the hydroxide ion of a basic solution and an acidic solution, so we can observe that for an acidic solution, the concentration of the hydrogen ion is greater than the hydroxide ion. For a basic solution, so that is the opposite, the concentration of our hydroxide ion is greater compared to the hydrogen ion. For a neutral solution, so the concentration is the same for both ions. We also have another definition, the Bronsted-Lowry definition of acids and bases. So according to this definition, the acid is a proton donor and a base is a proton acceptor. So for an example of this equation, we have here our HCl. When we are going to put HCl in water, so it will form the hydronium ion, H3O plus, and our chloride ion. So based on our Bronsted-Lowry definition of acids and bases, saan dito yung ating base? Saan dito yung ating acid? Sa apat. No? So we have 4 molecules here in our reaction. So saan dito yung ating base and saan naman dito yung ating acid? So water ang base. So tama, no? Bakit base ang water in this particular equation? Bakit siya base? Because nag-accept siya ng hydrogen ion. So, yung ating water dito, meron siyang kita naman ninyo, meron siyang dalawang hydrogen ion. So, it is considered to be a base because, again, our definition of a base is that it is a proton acceptor. So, when we say proton, that refers to our hydrogen ion. So, when water, H2O, will accept a proton, it will form hydronium ion or meron na siyang tatlong H, H plus. And saan galing yung kanyang hydrogen ion? So itong extra hydrogen ion here comes from the HCl. So yung HCl will lose a hydrogen ion and this hydrogen ion will bind doon sa bakanting space na meron dito sa ating water. So merong bakante dito na electron pair, kaya yung ating hydrogen ion here will be attracted to this one. So because our water will accept an H plus ion, so it is considered to be a base. It is a proton acceptor, while our HCl here is our acid because it is a proton donor. It will donate its H plus ion to water. So when this will happen, hydronium ion will be formed and chloride ion will be formed. So our hydronium ion is considered to be a conjugate. It's considered to be a conjugate acid, while chloride ion is regarded as a conjugate base. So bakit tinawag siya na conjugate acid? Tinawag siya na conjugate acid because it takes an extra hydrogen ion or H plus. This molecule here is considered to be a conjugate base because it loses a hydrogen ion and also it has a negative charge. Yung hydronium ion, it has a positive charge. So usually, pag ang molecule is positive, it is usually an acid. Pag negative naman, it is a base. So we have here another example of the acid-base reaction. We have here our NH3 or ammonia. When ammonia will be combined with water, it will form ammonium, NH4 plus, and hydroxide ion. So our ammonia here is considered to be is it a base or a acid? Ammonia, NH3. Is it a base or an acid? Ano yung ammonia? Is it a base or an acid? So it is a base. No? Ammonia is a base because it will accept a proton. It will accept a proton. So dito meron siyang tatlong hydrogen ion. So it will accept no another hydrogen ion. So magiging apat na ngayon yung kanyang hydrogen ion. So it will form NH4. Saan galing yung kanyang hydrogen ion? No, it comes from water. So water therefore is an acid, no, because it will donate. It will donate its hydrogen ion to NH3. So it will form NH4 and hydroxide ion. So NH4 is so ito yung tinatawag natin na conjugate acid. The hydroxide ion is our conjugate base. Conjugate base siya because it has a negative charge. And it loses hydrogen ion. This is considered to be a conjugate acid because it accepts or it takes hydrogen ion and it has a positive charge. So therefore, an acid in an acid-base reaction will always form an acid will always form a conjugate base, while a base will form the conjugate acid. The same is true for here. You know, yung ating base will form a conjugate acid, and our base here will form a conjugate base. Our acid here will form a conjugate base. So therefore, para ma-form natin yung ating conjugate acid, from our base, we just have to add a hydrogen ion to our parent compound. So for example, for water, para mag-form siya ng conjugate acid, mag-a-add ka lang ng hydrogen ion sa ating water. So when we are going to add hydrogen ion sa water, it will form hydronium ion. To form conjugate base, you just have to, so ito yung ating conjugate base. water, then we have here our hydroxide ion. So this is an acid. This is our conjugate base. So to form a conjugate base no, from a substance, you just need to remove a hydrogen ion from that particular, from our parent compound. So in this case, we have water. So when we are going to remove a hydrogen ion from water, this will form OH minus. So we decrease the charge by 1 and we remove a hydrogen ion. So magiging, ano siya ngayon? Magiging OH minus. So dito naman sa ating conjugate acid no, from our base, yung ating charge will be from 0 to plus, no, to plus 1 because we added hydrogen ion to our parent compound. So the hydronium ion is a hydrated proton. So when the water accepts a proton from an acid, the product is a hydronium ion. So hydronium ion is formed when water will accept a proton from our acid. So for example here, this is our yung ating no, hydronium ion, and this will be formed when our water here will accept a proton that comes from our acid. So HCl here is our acid. So because it donates a proton, so yung kanyang proton ngayon ay malilipat dito sa ating water. So pag mag-accept yung water ng hydrogen ion, so this will form a hydronium ion. So this is also another illustration of our hydronium ion. So our proton here comes from our acid. It will attach to our water to form hydronium ion. Okay, so we'll just continue this next meeting tomorrow. I will just upload yung ating lecture sa ating VLE.